Assalamu alaikum. Today is our third lecture of DSP, in which we discuss about the systems, what actually the systems are. System process signals to create other signals. As we previously discussed, that system is actually that process or one signal to create another signal. For example, we have xn signal, the system work over it and creates y of n. Further contents in today's lecture we are discussing about different topics, which are types of systems, properties of system, proof with examples, convolution and correlation, and applications. Now, first of all, types of systems. In types of system, we have three types of systems: serial or cascaded, parallel system, and feedback system. In serial system, we have the transfer functions in series. H1 and H2 are system filters. In parallel systems, we have transfer functions H1 and H2 in parallel, and in feedback system, we use the part of output to reproduce the output. Part of output is taken as input. This is called feedback. Output part is used to modify input. Then comes properties of systems. In properties of system, we have three properties, basic three properties: causal or non-causal, linear or non-linear, time invariant or time variant systems. In causal or non-causal, in causal systems, we take the present and past values. If we have any future value in our output function or a given function, then it is called non-causal function. For example, here we can see x n plus 3 is future value, so it is non-causal system. But when we have present or past value, then it is causal system, otherwise non-causal. Then comes linear or non-linear. Linear systems are those which satisfy these two properties: additivity and homogeneous. If the function is additive and homogeneous, then it is called linear. If one of the properties is not satisfied, then it can never be linear function. If any property doesn't satisfy, then the function is non-linear. Additive property is when we add two systems, inputs of two systems, then we get the output of two systems. And if we add separately and apply, passing through the system and added after the applying of system, then it is equal, both are equal. Then homogeneous if we multiply any constant to the input, the same response we can see in the output, then it is called homogeneous. If both the properties satisfied, then it is linear function, otherwise non-linear. Then comes time invariant or time variant, that varying with time. If we have n minus n naught shift in the input, then there must be n minus n naught shift in the output, then it is called time invariant, otherwise time variant. As in the contents of today's lecture, we are telling about that we are prove these properties with the help of examples. Then in examples, in linear system, we have yn is equal to function is yn xn minus 2 xn minus 1. It is a linear system because when we take two inputs, let's take two inputs x1 and x2, when passing through these systems separately and then added after passing through the system, it has the output. And if we add the two inputs before and then passing through the system, it is satisfied. But the second one, yn is equal to xn plus 5, is non-linear system because in this coefficient is involved. So when collectively we are added and passing through the system, then it becomes plus 10. So when constant term is involved, it is flopped due to the constant, so it is non-linear system. Then the third example is yn is equal to xn minus 2 xn minus 1. In causal system, we know about the condition: if present and past value is involved, then it is causal. So here is the present value and here is the past value. In the next example, yn is equal to xn plus 3. Also the present value is involved, but there is another value which is future value. So because of this future value, it is non-causal system. Then yn is equal to xn minus 2 xn minus 1. It is in time invariant because when we apply the change in input with respect to time, then there is a same change in the output, so it is time invariant. And this example is time variant. So according to the contents of our today's lecture, we covered about types of system, properties of system, proof with examples. Now comes to convolution and correlation. What actually the convolution and correlation is? Generally, we have a system yn is equal to summation k minus infinity to infinity x of k h of n minus k. We know about the impulse response is h of n. In convolution, we convolve two systems x of n convolved with the h of n transfer function. For example, we have a system yn is equal to xn minus 2xn minus 1 plus 3xn minus 2. If we calculate yn manually, so the given xn is stated there. At 0 it has one value, 1 has one value, and at 2 it has one value. Then now first of all we find y of n. We have x of n, then we put every value of x of n here and calculate the yn. So manually we calculate from this x of n, y of n, all these values of yn. Then if we find h of n, in case of h of n, we have the input function is impulse of n, and we already know about impulse 0 is equal to 1. So when n is equal to 0, then impulse function gives value, otherwise it is 0 everywhere. So in this you can see that when it becomes 0 it gives value, when it becomes 0 it gives value. So h of n has different values at h0 1, h of 1 minus 2, h of 2 3, all other values are 0. Now we have y of n and h of n. In convolution we learned that when we have to convolve two functions, we flip and slide. First we flip our function and then slide. Here you can see that summation n minus infinity to infinity x of n h of minus k plus n. Minus k means that we flip our transfer function. That means h of minus k. As in the previous, we have the values at h of n is 0. It has value 0 1. At 1 it has value minus 2, and h of 2 it has value 3. But when we inverse this function, flip this function h of minus k, then we has 0 at 1, and then 1 we have minus 2, but here we have minus 2 at minus 1, and at minus 2 we have 3. So we flip our h minus k. X of n, we already know that from the previous, x of n is 0 to 1, 1 to 1, and 2 to 1. Now we have to h of minus k. First h of minus k, we convolve x of n and h of minus k plus n. Flip and slide. Here is the flip function. Now we slide until all the values are matched. But when we flip it one more time, h minus k plus 3, it is out of the boundary. So here we can flip. In this way we can calculate our convolution. In convolution we flip and slide, but in correlation, in this we only slide relation of signal with other. In correlation we have techniques autocorrelation, cross correlation, but remember one thing, in convolution we only flip and slide. We flip the function, then slide it and convolve it to the function. But in correlation we only slide. Last but not the least, we have applications of correlation. In applications of correlation, as we already discussed about the correlation, but actually the correlation. In correlation, we relate one signal with respect to the other, and in correlation, we only slide, irrespective of convolution, in which we slide and flip and slide. In applications of correlation, we have detection of waveform in noise, antipodal scheme, threshold detector. Antipodal scheme is basically when we have one signal negative with respect to the other. In cross correlation, we have different applications, involves pattern recognition, signal detector, weather forecasting, security system, and water traffic monitoring. That's all for today. Thank you. Thanks for watching.